Hello all, I am Dr. Pravas and in today's class, we'll discuss about some problems or some examples of S attribute and L attribute definition. Okay. See. Here question is, consider the following STT. Consider the following STT that fill the type information, that fill the type information into the symbol table. Okay, that fill the type information into the symbol table where type is an attribute, and S dot or S type is an synthesized attribute. And I type is an inherited attribute. Okay, so here some important information is given. What type is an attribute? S dot type is an synthesized attribute, and I dot S dot type here, and I dot type is an inherited attribute. Okay, now we'll construct the we'll fill the type information. Into the symbol table. Into the what? Symbol table. How to fill the symbol? Just say one STT is given, means syntax data translation is given. First, we'll discuss. This is the example of S attribute or L attribute definition. First, we'll discuss. Just say, since the given STT contains both S type, it contains both S type and I type. S type means synthesized attribute. See, S type means what? Synthesized attribute. And I type means what? Inherited attribute. Just see, S is not S dot type, is simply S type. S type and I type is simply we can write I type. Okay. Since it contains both inherited and synthesized attribute, so it is the example of what? L attribute definition. Is very simple. It is the example of L attribute definition. L attribute definition. Okay. First, we'll take one example. Just say, what? Int A, comma B, comma C. Int A, comma B, comma C. That means this is my input string. One input is given. This is my input string. First, we'll construct the annotated parse tree. For the given input string. Okay, see, first we'll construct the given input string. How? Just see. S to TL, S to TL, then T to int, then T to int, then L to what? L comma ID, L comma ID, then L comma ID, then we will store this one L comma ID, then L to ID. Just see. Here this is int. This ID let it is A. This ID let it is B. This ID let it is C. Means A, comma B, comma C. Int A, comma B, comma C. And this is the given. This is the what? This is the given parse tree. This is the constructed parse tree. This is the constructed parse tree for the given input string. Okay. Now we'll convert this parse tree as annotated parse tree. Just see, S to TL. Here S to TL means what? L dot I type equal to T dot S type. Means here in STL, this production, the T is S type. Just see, S type. Just see, I'm just filling this information. What? T is S. Just use. Okay. Here T is S type and L is I type. Here L is I type. Okay, I'm just using the same color. T dot S type. This is very important. Okay. Then L to L comma ID. Just see L to L comma ID. L I type equal to L dot I type. Means this L is also I type. L is here I type. I type. And this is also I type. Right. So now we'll find out the value. Now we'll find. So what question is, just say, okay, this is my annotated past. This is my annotated past for the given input string. For the given input string. Now here, what is the question? Consider the following STT that fill the type information. That fill the type information into the symbol table. Now we'll construct one symbol table. Just see here, we'll construct one symbol table. This is lex. These are the token. Next type. Then let it is memory. Okay. So how many variables are here? A comma B comma C. A, B, C. There are three variables. So we'll fill the type information of these three variables. Okay. So see. Okay. First we'll evaluate. Important point is first we'll evaluate this type, means attribute information, because this is the annotated past. We'll evaluate the attribute informations like T dot S type, L dot I type, L dot I type, like this. Okay. First we'll evaluate the all informations. So first we'll evaluate T dot S type, means this information. Okay. Since just say T dot S type, T dot here, T dot, just see here, I'm using some other color. Just see here, T dot S type. T dot S type means it is a synthesized attribute. Since T dot S type is a synthesized attribute, T dot S type is a synthesized attribute. So we'll evaluate all, we'll evaluate all synthesized attribute in the form of children. Here children value is given what? Integer. So here T dot S type is nothing but it will be what? Integer. So T dot S type is integer, because since T dot S type is a synthesized attribute, every synthesized attribute will be evaluated in the form of what? Children. Okay. So T dot S type is int. Okay. Next we'll evaluate what? L dot I type. Next we'll evaluate this value, L dot I type. Okay. That's it. That means we'll assign this value, this integer value to here. Okay. That's it. How to evaluate L dot I type? Since L dot I type is an inherited attribute, every inherited attribute will be evaluated in terms of parent or left sibling. So here first we'll check parent. There is no value for parent. So since there is no value of parent, so we'll evaluate L from where? Left sibling. From where? Left sibling. Since T dot S type is int, so L dot I type is nothing but it is also int. Okay. Now we'll see. So then we'll evaluate what? L dot I type. We'll evaluate this node. Okay. Since L dot I type, L dot I type is an inherited attribute, so it will evaluate. Why? How to evaluate? We'll evaluate this L dot I type in terms of parent. Here parent value is nothing but what? Integer. So I will assign int value to here. Just say. Next, we'll evaluate this ID. Here ID is nothing but important point. Here ID. This ID is nothing but this is inherited attribute. Inherited means I type. This ID is nothing but inherited attribute. Okay. Important point. I dot type, right? Okay, say this ID dot I type and ID dot, since it is an inherited attribute, so this C will assign this C. This ID dot I type, since ID dot I type is an inherited attribute, it will evaluate, means it will take the values from left sibling or from this value, means this L dot I type, means it is also int, this is also int. So this ID dot I type can take the values from either left sibling or parent, means this C is nothing but what? It is a int type. It is nothing but what? It is a int type. Just see. So C will fill the information. C is nothing but it is a identifier. It is a what? Identifier. And type, its type is what? It is nothing but int, means integer. Let it will take the memory like what? 2 bytes. Okay. Now we'll fill this L value. Since it is a L dot I type is a inherited attribute, it will take the information from parent. Parent is nothing but what? Integer. So this value is nothing but integer. Okay. Since ID dot I type is an inherited attribute, it will take the information from parent or left sibling So B is nothing but, or this ID is nothing but which type? This is also int type. Now we'll fill the information of B. So B is also identifier and type. Its type is what? Integer. Its type is nothing but integer. It will take the memory like 2 bytes. Okay. Now we'll evaluate this ID dot type. This ID dot I type is nothing but what? It is an inherited attribute. Inherited attribute, it will take the information from what? Where? Parent. Since parent is nothing but integer type, so it will, this A is nothing but it is integer type. So A is nothing but it is an identifier, its type is nothing but it is integer, and it will take the memory 2 bytes. Okay. So how to fill the information? It is nothing but just say here L dot L2, just try to understand the syntax related translation. Here S to TL, L dot I type is equals to T dot S type. S to TL means T dot S type, here L dot I type. Similarly, in this way, L to L comma ID is nothing but what? L I type equals to L dot I type. L to L comma ID, or here L comma ID. This L dot I type means this L dot I type is nothing but what? This one means L dot I type. And R type ID dot name. ID dot name means what? This one. ID dot name and is L dot I type, means its type. L dot I type means this ID is nothing but which type? This ID is nothing but inherited type. Since ID is an inherited type, so it will take the information from either parent or left sibling. Okay. So we'll just fill the information. It's nothing but it's just like a function. It will store the information for, it is for means each and every variable into the symbol table. Here L to ID is nothing but what? R. Type information means type. This type information means what we will store? ID dot name and its type. What? L dot I type. will store the information. Store the information of IDs. IDs like IDs or variables like what A, comma B, comma C. There are three variables, so we will store these three variables into the simple table. Okay. So next we'll see one more example. This is very simple example. Consider the following STT. Consider the following STT. What? This is the given STT. Okay. First, we'll say the given STT is L attribute definition or S attribute definition. The given STT is what? L attribute definition or S attribute definition. Just say all semantic rules here. All semantic rules are the end of the each production. Just you can see end of the production. Here end of the production. Here end of the production. Here end of the each production. Here end of the production. Here end of the production. So it is nothing but it is the example of S attribute definition. S attribute definition. Important, one more important point. Every S attribute definition is also called L attribute definition. Every what S attribute is also called what? L attribute definition. So we can also call it is L attribute. We can also call it is S attribute definition. Okay. So now just say find the output of the following input string. Here input string is given 5 plus 2 into 3. Okay. First we will construct the parse tree, right? So L2, just say this is E and print E dot val. Then we will explore this E plus T. Then we will explore this T at T2 T star F. Then we will explore F2 norm here. Then we will explore the T2 F, this one, F2 norm. Then E2 T, let's see E2 T and T2 F, F2 norm. Okay. So just say will are the type information or attribute information. All are what? Val is an attribute information or it is the attribute information. So L dot val, this is val, this is val, 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 right? So here we'll assign some value. Just say f val dot norm. F2 norm is nothing but what? F dot val equals to norm, means this norm will assign. So here we'll assign 5, here we'll assign 2, here we'll assign 3. So means 5 will assign to here, 2 will assign to here, 3 will assign to here. Okay. T2F, just see T2F means what? T dot val is nothing but F dot val. So we'll assign 5 here. So we'll assign 2 here, right? Then E to T, just say E to T is nothing but what? E dot val equals to T dot val, means we'll assign 5 simply here. So T dot val equals to just T to T star F, just see T to T star F. T to T star F is nothing but what? T dot val equals to T dot val into F dot val, means 2 into 3 means 6. Okay. Then E to E plus T, just see E to E plus T is nothing but what? E dot val equals to E dot val plus T dot val, means we'll 8. 5 plus 6 equals to 11. Okay, then we'll print what is the L dot val. L to E means what? L to E plus what? Print E dot val means we will print this 11 print E dot val. Here value equals to what? 11. So this value is nothing but 11. Okay, so this is the end of S attribute and L attribute definition. In the next class we'll discuss about intermediate code generation. Okay, this is the fourth stage of the compiler or fourth phase of the compiler. We'll discuss in the next class. Okay, thanks for watching.